Sweet. Okay, so Chris already covered my background, so I'm just going to skip over that, but I just wanted everybody to know that I kind of know what I'm talking about, even though I'm not a climate scientist. I'm kind of like the next best thing. So I wanted to give a little plug to skepticalscience.com because there's only so much stuff I can cover in 25 minutes, and that is one of the really go-to websites to learn about basic climate science. So it's a website run by a group of international volunteers, and what we do is we read what peer-reviewed climate science research says, and we kind of translate that into plain English so that people can understand it. And you can see on the left side of the page there, the backbone of the website is a myth rebuttals database. So we've got close to, I think, 200 myths now, where when somebody submits a myth or we hear about a new myth about climate science, we go to the peer-reviewed research, see what it says, and then we write about it. And I'm going to talk about the top 5 myths, the most used climate myths in my talk. So one nice feature of the website, at the top you can see we have basic, intermediate, and advanced levels of our myth rebuttals. And so if you just want to know a really basic explanation of what the science says about a myth, you can go to the basic level, and we'll just have a few paragraphs and usually a graph. And if you want to know more details, you can go to the intermediate or the advanced level. And then we also have a really nice feature, smartphone app. If you scroll to the bottom right margin of the page, you can click on that and download the smartphone app, and it looks like this. And so this can be a really useful tool in certain situations, like if you're at Thanksgiving and your uncle corners you and starts telling you global warming is caused by galactic cosmic rays. So then you can pull out your smartphone, open up the Skeptical Science app, type in galactic cosmic rays, and hand it to him, and let him read what the peer-reviewed research said about that. And then this is just my Guardian blog. It's called Climate Consensus to 97%, which I run with my colleague John Abraham, who's a scientist in Minnesota who also does some climate research, so that's worth checking out. So now on to the good stuff. So the big question most people have is, how do we know humans are causing global warming? And the most popular #1 myth in our database is the climate has changed naturally in the past, which is true. That's not the myth. The myth is that that somehow implies that the current climate change is probably natural too. And so that's like if you find a dead body with a knife sticking out the back and you say, well, people have died naturally in the past, so this guy probably died naturally too. It's a logical fallacy. And so climate science is, it's kind of like doing crime scene investigation, in that you're looking at all the available evidence and the clues and then trying to figure out who that points to as the culprit. And I got Benedict Cumberbatch in my talk, and so that's mission accomplished. So there are a whole lot of what we call fingerprints of human-caused global warming. There are pieces of evidence that point to humans as the cause, or at least consistent with human-caused global warming. So like there's nights warming faster than days, there's winters warming faster than summers, there's the upper atmosphere is cooling while the lower atmosphere is warming. And 2 key ones is that there's less heat escaping into space and more heat returning to Earth. And so that's a key signature of the increased greenhouse effect. So the greenhouse effect, you get light coming from the sun. It comes as ultraviolet, so it's visible, and infrared light. And the greenhouse gases in the atmosphere, they only absorb infrared light. So most of that comes through the atmosphere and reaches the Earth's surface, and the Earth absorbs it and then radiates it back out as infrared light, which is basically heat. And then the greenhouse gases in the atmosphere absorb that, and then they re-radiate on all different directions. And some of it they send out back into space, and some of it they send back down to Earth. And when it's sent back down to Earth, that warms it more. So you get more greenhouse gases in the atmosphere, you get more heat trapped, and you get more warming. So this slide shows what the Earth would look like if it were in an energy balance with the same amount of energy coming in as going out. We have satellites measuring that, and we have an energy imbalance right now with more coming in than going out. And so then the question is, do you have more coming in from the sun, or do you have less going out? And so the second most popular myth in our database is that global warming is caused by the sun. And so you can see the bottom data here, the blue data is energy reaching the Earth's surface from the sun. And you can see it was increasing from 1880 until about the mid-1900s, and then after that it flattened out, and actually it's been going down a little bit since then. And on the top you can see that's global surface temperature data in the red. That was going up, and then it flattened out a little bit, and then it's been going up since about 1970. And so that tells us a couple things. It tells us, one, the global energy imbalance since 1960 can't be caused by more energy coming from the sun, because the energy coming from the sun has actually been decreasing a little bit. And it also tells us that warming since 1970 can't be caused by the sun either. And there's another interesting feature about the solar data, that the increase from about 1900 to 1950, it's only a change in 0.05% of the energy reaching the Earth from the sun. And so we're actually really lucky that the sun is very stable. The amount of energy coming from the sun doesn't change very much, which also means that our climate's really stable. And so we've been really lucky in that respect. So in this chart, again, the red data is global surface temperature data, and then the green and the blue is atmospheric carbon dioxide measurements. And so you can see they don't go up perfectly together because CO2 isn't the only thing that influences the temperature, but they go up pretty well together, especially since 1970. So again, that's more evidence that the increase in temperature is caused by the increased greenhouse effect. And then this chart shows 8 papers that I looked at. So I looked for papers that specifically investigate what's causing global warming, and how they do that is they combine statistics and measurements and climate models, and they try to tease out which factors are causing global warming. And so I grouped these together into human causes and natural causes. You can see the human causes on the left. They're all right around 100% of global warming caused since 1950 or so. And on the right, the natural causes, they're all pretty close to zero. So there's pretty strong agreement in the scientific literature that about 100% of global warming since 1950 is human caused. And then the latest Intergovernmental Panel on Climate Change report, it said with 95% confidence, humans are the main cause of global warming since 1950, and their best estimate was, again, humans are responsible for about 100% of the global warming since 1950. And 95% confidence is about the same confidence scientists have that smoking kills, so very high confidence in human-caused global warming. And then this graph is from a paper that my colleagues and I published last year, where we took 12,000 peer-reviewed papers published in the last 20 years, and we read their abstracts, which is the paragraph-long summary at the beginning of each paper, and saw what they said about the cause of global warming. And then we also emailed the scientists who published the papers themselves and asked them, what does your paper say about what's causing global warming? And so our abstract ratings you can see in the blue data, and then the author self-ratings, the scientist self-ratings, you can see in the green data. And so you can see, even since the early 1990s, there's very strong agreement on human-caused global warming. Over the whole period, it was 97% consensus, and actually in 2011, it reached 98% consensus that humans are causing global warming. There's also National Academies of Science, which are basically groups of the best scientists in every country around the world. None of them disagree with the consensus, and we found 80 examples of National Academies of Science agreeing that humans are causing global warming. So the problem is there's this thing we call the consensus gap, where there's this reality of a 97% expert consensus, but if you ask the public, and this is actually the 4th most popular myth in our database, that there is no consensus. If you ask the public what percentage of scientists agree that humans are causing global warming, the average answer is 55%. So that's a very big gap, 55% to the actual reality of 97%. And it's also a problem because research has shown that if people are aware of the expert consensus, they're more likely to accept the science, and they're more likely to support taking action to address the problem. And so the fact that half Americans don't realize there's a consensus is like a big roadblock to taking action to solve the problem. And so our paper was kind of an effort to reduce the consensus gap and increase people's awareness of the consensus, and we had some luck with that. We got 2 tweets from the presidential Twitter account, which was cool. It was also the 11th most viewed paper, or most talked about paper of 2013, which is also cool. So hopefully we're making a little bit of headway on that. So if there's one thing you remember from my talk today, 97% consensus. So the 5th most popular myth in our database, and actually I want to do an informal audience poll on this. Raise your hand if you've heard the myth that global warming paused or stopped 15, 16, 17 years ago. Quite a bit, close to half the audience, I think. So that's the 5th most popular myth in our database overall, but in recent years, it's become probably the most popular. It's been in a lot of media stories in the last year or 2. And so this myth is wrong for 2 main reasons. And the first one is that it's focusing on global surface temperatures, or basically temperatures that are part of the atmosphere. And in reality, most of global warming and that global energy imbalance I was talking about, over 90% of it goes into the oceans, and only about 2% of it goes into warming the atmosphere, another 2% warms the continents, and a few percent more goes into melting ice. And so if you want to talk about whether or not global warming is paused or continuing, you have to look at all of that data. And so this chart is from a paper that my colleagues and I published in 2012, where we put together all the data to see what it said about global warming. And so you can see the blue data, light blue data is the shallow oceans to 700 meters. The dark blue is ocean temperatures from 700 to 200 meters, 2,000 meters. And the red is land warming, atmosphere warming, and ice melting. And so when people say global warming paused or stopped 15 years ago, they're only looking at a sliver of that red data and they're ignoring all of the blue data. And actually they're ignoring most of the red data too. So if you look at all the data together, you can see there's no sign of a slowing. If anything, global warming has actually been accelerating over the past 15 years. And so when people focus on surface temperatures, well, an important thing to remember is that since most heat is going to the ocean, oceans have cycles where sometimes the ocean is absorbing more heat, sometimes it's absorbing less heat. And sometimes it's absorbing more heat, there's less going into the atmosphere. And so you kind of get a cyclical pattern in global surface temperatures that can be mistaken for a pause in global warming. And let me see if I can get this to work. So this is a graph or a figure I created it's called the escalator. You got click the play button. Move the mouse and click the play button. Technology. So you can see pause, 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 pause. And then if you look at the long-term trend, well, the long-term trend is upward and very clearly so. And that long-term trend is what's caused by the human-caused global warming. So, okay, why are we worried about this? So the third most popular myth in our database is that global warming is not bad and it's nothing to worry about. And so I think this chart shows really clearly why we're worried about it. The blue data at the bottom, that's global surface temperature reconstruction over the past 11,000 years or so, basically since the last ice age. And then the red is temperatures over the last 100 years, and then where we're going in the next 100 years. And so we're right about there, pretty close to the top of where it's been in the last 11,000 years. And then the three red dots show where we're going in 2100. And so there's a range of values. We don't know exactly how sensitive the climate is to the increased greenhouse effect. So basically, and this is in business as usual. So business as usual, we're best case scenario, it's that low sensitivity dot at the bottom, most likely at the middle, and then worst case scenarios at the top. And so the Roman Empire was back there, there's ancient Greece, there's ancient Egypt. The start of human civilization was somewhere back there, and so basically we're nearing the point where we're going outside the range of climate the climate's been in the last, and basically the history of human civilization. And we're going well outside of that if we continue with business as usual greenhouse gas emissions. One back. Okay. So, for California, there's some specific things we're worried about. One of them is wildfires. So, for example, the Yosemite Rim Fire last year was, I think, the third largest in state history. And this graph is from a paper published a couple years ago. It was looking at how wildfires are going to change in various greenhouse gas emission scenarios. So this one is, again, from business as usual scenario. And it's 2085 compared to 1975, how wildfire is going to change. And anything orange to red is at least a doubling of the area burned by wildfires in each wildfire season, so basically each year. And so you can see for Northern California in particular, increasing wildfires is a big concern if we continue with business as usual.
Did you mean 1985 or 2085?
2085, did I say 1985?
No, it's just, how can you go from past to...
It's changed. The graph was a comparison of how much more wildfire is going to burn from in 2085 as compared to how much burned in 1975. So basically it's going to double in most places. And then the drought's another concern. Obviously we're finally getting some rain, but most of the state is in serious drought conditions. And so this has been caused by what they're calling the ridiculously resilient ridge, which is an awesome name. And So it's a high pressure ridge off the California coast that's pushing all of our rain up into Canada and Alaska. And so the question then is there a connection to climate change? And so in 2004, there was a paper published by a couple of scientists at UC Santa Cruz. And so you can see the headline, climate studies shows disappearing Arctic sea ice could reduce water availability in the western US. And so one of those scientists published this paper, this chart in a paper in 2005, and you can see in the red, there's this high pressure zone off the coast of California. And then you can see that's what the high pressure zone looked like last year. Very similar. And so, I mean, that could be a coincidence, and it could also be evidence that their hypothesis is correct. And then there's also a hypothesis that the loss of Arctic sea ice could be causing the polar vortex. So the idea is that normally the jet stream goes from west to east in a pretty straight line, but when the jet stream slows down, it kind of meanders, and then it creates this pattern that allows Arctic air to come into the United States. And so that's why most of the country's been really cold, but we've been having 7-degree temperatures and drought. And so, next slide. Okay. And so the idea is that there's Arctic sea ice basically acts as a barrier or a lid between the ocean and the atmosphere in the Arctic. And when you lose that barrier, when the Arctic sea ice melts away, then more heat comes from the ocean into the Arctic atmosphere. It warms up the Arctic atmosphere, and then there's less of a temperature difference in the Arctic atmosphere and the lower latitudes. And that can potentially cause this slowing and meandering of the jet stream. It can cause more polar vortexes. So I put the asterisk to the top because there's a big caveat that this is very breaking new research. There's not a consensus about this. It's just a possibility that some climate models are showing this could happen with more high pressure systems off the California coast and more meandering jet streams and more polar vortexes. So we don't know for sure this is going to happen. There is some evidence for it, but the idea is that when you mess with the climate, weird stuff happens and you get weird weather, and it's kind of hard to predict exactly what's going to happen. So it's a risky situation. Okay, so can you try to start the movie? There's another play button on the bottom there. So this is a video that another colleague of mine created. Go back, forward. Like that.
Just go inside.
Alright. So the left side shows the ice cube represents the volume of Arctic sea ice in 1979, and the right side represents how the volume is changing each year since 1979. And you can also see the data plotted in the red in the background. So you can see by the mid-2000s, the volume is down to about half what it was in 1979, and it just keeps going down and down and down. And last year wasn't too bad actually, but you can still see the long-term trend is really steeply downward. And at this point, we've lost over 70% of the Arctic sea ice in the last 3 decades. And this is a chart. It goes further back in time of summer Arctic sea ice extent rather than volume. It goes back to 1870. So you can see it's pretty flat until about 1970, and then it takes that downward curve. One more. And so this one goes even further back in time. It's a paper published in 2011 looking at Arctic sea ice extent over the last 1,450 years. And again, you see it's pretty stable. There's some variation, but then once it gets to the late 1900s, that blue data, it really takes that nosedive. So you can see this is what scientists are worried about, that we're creating this really large change. It's pretty unprecedented in recent history, and that's why we're worried about the climate change is going to cause. So there are some ways that we know climate change is certainly going to contribute to California drought. There's the loss of snowpack, which one thing is a problem for the winter sports industry, but it's also, the snowpack is like our natural water storage that as it melts throughout the year, it refills our reservoirs. There's the fact that as temperatures warm, precipitation falls more as rain, less as snow, and so that causes the snowpack to shrink. More precipitation tends to fall as downpours because there's more water vapor in the atmosphere because of evaporation. And so that means less absorbed by soil, there's more runoff. You also get faster snow melt, so again, the snowpack shrinks earlier in the year. You get more evaporation from reservoirs and drier soil due to higher temperatures, which is another problem for water storage and drought. And then you get these potentially changing precipitation patterns. So as a general rule, wet areas are going to tend to get wetter and dry areas are going to tend to get drier, but for California in particular, it's a little hard to predict. We're kind of in a question mark zone, where the Southwest, we know it's going to get drier. But California, at least Northern California, is a little bit of a question mark. And then there's this added question mark of the potential of more high pressure reaches off the coast because of loss of Arctic sea ice that could potentially cause more droughts too. That's more of a question mark, it's just a possibility. And then as a coastal state, we're also worried about sea level rise. So this map shows what sea level, or what the Northern California will look like if there's a 1 meter sea level rise. So you can see there's a lot of flooding in the delta, and then flooding starts to get up towards Stockton, towards southern Sacramento, Fairfield, and Napa. There's a lot of flooding in the Central Valley area near the bay. And so that's from 1 meter of sea level rise, and again, in business as usual greenhouse gas emissions, 1 meter is very possible by the year 2100. So that could potentially be California 2100 if we continue with our current path. There's also the more moral and ethical problem that the countries that contribute the least to climate change tend to be the most vulnerable to it. So on the top you can see the countries that release the most greenhouse gas emissions are in red, the least are in blue. And then the bottom chart shows the countries that are most vulnerable to climate change are in red. And so you can see in particular it's a problem for Africa and Central and South America. And so there's a couple reasons for that. One is that the poorer countries tend to just have less wealth, less resources available to adapt to climate change. And the other problem is that they tend to be close to the equator, and countries close to the equator have pretty stable, warm weather all the time. And so a change in the weather or a change in the climate is a relatively big change for them when they're used to stable weather conditions. So as a risk assessor, I like to talk about climate change in terms of risk management. So we don't have an emergency backup planet. We can't just go to Mars if we mess up this planet. So it's a good idea to take care of the planet that we've got. And then this is a cartoon that my colleague John Cook, who founded Skeptical Science, recently put together. And so the top right frame, it shows a comment from a climate scientist, Judith Curry, who's kind of becoming one of those 3% of climate scientists who's skeptical about how much global warming humans are causing. And so just last year she said, I can't say myself that doing nothing about global warming isn't the best solution. And technically we can't say that doing nothing isn't the best solution, but from a risk management standpoint, that's the complete wrong approach to take. So a couple examples, for example, smoking is a good one. I can't say for sure if I smoke that I'll get cancer, but I'm increasing the probability of it, and I'm basically creating a scenario where I'm making a really bad situation more likely to happen. And so from this approach, you would say, well, I can't say smoking's not a bad idea, or I can't say smoking's not a good idea. But if you want to reduce the risk, then you would stop smoking. And that's why fewer people smoke now than did a couple of decades ago. Another example is with home insurance. If you buy a house, you get homeowners insurance, and you probably get fire insurance. So even though there's a really small possibility that your house is going to burn down, you want to be prepared for that scenario in case it happens, because it's such a bad thing. You know, your house burned down, there goes your entire financial portfolio. So it's the same situation with climate change. Next slide. And so I also like to use this analogy that we're basically putting our carbon emissions on a credit card right now. So there are inevitable costs of climate change. So for example, when you release carbon emissions that cause global warming, that cause the oceans to warm, that fuels stronger hurricanes, and it also causes sea level rise, and that increases storm surges. And so those things, when a hurricane hits, they cause the damage of the hurricane to be larger, and then you have to pay for those costs down. Or another example, global warming causes more heat waves. Heat waves are bad for crops, and so then you get crop damage, and then food prices go up, and everybody has to pay higher food prices down the line. So basically, we're deferring the cost instead of paying the cost of the carbon emissions now, we're paying them down the line. And the other problem is that paying for the cost of climate damages tends to be a lot more expensive than paying the cost to reduce greenhouse gas emissions up front. And so it's basically like we're building up interest on the credit card by not paying the price to reduce the emissions now. And so the group I'm involved with, Citizens Climate Lobby, advocates for putting a price on carbon emissions as a revenue-neutral carbon tax. So that if once there's a price on carbon emissions, people can sort of make informed decisions because they're aware of the actual costs of the purchases they make. And in California, we have a cap and trade system, which is a good start, but we need national and international action because California can't solve the problem by ourselves. And so if you want to pass legislation on a national level, you need bipartisan support. And to get bipartisan support, we need conservatives on board. And more conservatives are starting to come around to support a revenue-neutral carbon tax because it doesn't increase excessive governments. And the money comes back to the citizens, which allows, so it's not exactly a tax, it's a fee with the revenue returned to citizens. And it's a small government solution. And so Jerry's going to talk more about that. So that's it. Thanks.